Okay, so today we're going to look at even functions versus odd functions. So you've probably heard similar terms if you watched any of the other videos, and it's because we classified exponents to different orders, and also we said whether it had an even degree or an odd degree. And it's kind of confusing at first, but an even degree function is different than an even function, and an odd degree function is different than an odd function. So we can make a couple guesses and predictions of what the behavior of a function might look like because of the degree, whether it's even or odd, except to know whether or not it's actually even or odd, there's a couple of criteria that it has to actually match up with. So for even functions, I'm going to go over this in a minute. We know that it has to have symmetry about the y-axis, have symmetry about y-axis. That is the first little bit of criteria that it must have. And that you could easily prove graphically if you had the graph of a function, but let's say that we have a function that's way too hard to graph. You could actually prove it algebraically, and to do that you have to prove that f of x, so the standard notation of the function, it has to equal f of negative x. And that looks confusing, but we're going to go over it. So how do we classify an odd function? Well, it's not all that different, actually. So an odd function, we know that it must have symmetry about the origin. And this is literally just, it has to have point symmetry or line symmetry. Symmetry about origin. And I labeled that number 2. Okay, well, whatever. We'll label this one number 1 then. And we know that for this one, negative f of x, so that must equal f of negative x. And it looks like it makes no sense because we're not used to seeing functions in this kind of notation, except it's really not that hard, and I'll hopefully be able to break it down for you so you can understand it a bit more, because it really isn't that challenging. So I'm going to do an example. Let's do f of x is going to be equal to 3x squared plus 2x. Okay, let me write that out. So we know that f of x equals 3x squared plus 2x. So that's our function. So we want to prove that this is either even or odd or neither, because who knows, it might not be symmetrical about the y-axis or symmetrical about the origin, and then f of x might not equal either of these things. So let's try to figure this out. So the first thing that we could do, let's see what the function would look like if it was negative f of x. And to do that, so negative f of x, it literally just means that we're going to distribute a negative to the entire function. So 3x squared plus 2x. So then we know that negative f of x will equal, and then we're going to distribute the negative out, so it would be negative 3x squared, and then a negative times a positive is negative minus 2x. So we already don't know. We already do know. Hold on, let me get a different color. This right here is negative f of x. There we go. And this is f of x. And for it to be an even function, it says that f of x must be equal to, it must be the same as f of negative x. And we can see between these two, they clearly are different. 3x squared plus 2x is not the same as negative 3x squared minus 2x. So we can write f of x does not equal f of negative x. So therefore, this function is not even. So maybe it's odd, so why don't we take a look at that? So for us to figure out whether this thing is odd, this is the most challenging part, surprisingly, and it really isn't that challenging. So f of negative x. So what does this mean? Like, how do I figure out what the function of negative x is? So we're literally just going to put in brackets, instead of an x, a negative x. and we're going to replace all the x's we see with a negative x in brackets. So 3 negative x squared plus 2, and then instead of an x, I'll write a negative x. And then we're just going to expand it. So f of negative x will equal, and then we know that negative x, I'm going to write this below over here. We know negative x times negative x, because this is negative x squared, that's going to be a positive number. It's going to be a positive x, because a negative times a negative is positive. So this will be actually just equal 3x squared, because a negative times negative is a positive, so it's going to be just 3x squared, because it's a positive x squared. So then plus, and then this, or not a plus, sorry. And then we know that a negative x times a positive 2 is going to be a minus 2x, right? So this one's going to be 3x squared minus 2x. Again, that's because the positive 2 times the negative x is going to be a minus 2x. So this one, we know this is the most simplified version that we could do in standard form of f of negative x. So let's look at all of these. These two, they look sort of the same at the beginning, but then they don't match. And then these two, these don't match at all. So every single one of these is different. So f of negative x does not equal negative f of x, because that's the criteria for our odd function. So then we can say, therefore, this function is not odd either. So if we want to do an overall statement, we could say, therefore, the function of x is neither